Hi friends, welcome to my channel Tales Academy. Today we are going to learn about Ncert Class 7 Chapter 1 Integers. As we know, the first numbers to be discovered were natural numbers, that is 1, 2, 3, 4, 5, 6 etc. up to infinity. If 0 plus natural numbers or 0 is added to the natural numbers, we get whole numbers. If we add 0 to the group of natural numbers, we get whole numbers. If we put the whole numbers and their negatives together, the whole numbers and their negatives, we get a new collection of numbers. That is, the whole numbers 0, 1, 2, 3, 4, 5 up to infinity plus their negatives minus 1, minus 2, minus 3, minus 4, minus 5 up to infinity. We get a new collection of numbers. It looks like minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6 up to infinity. And this collection of numbers is known as integers. That is, whole numbers and their negatives, we get a new collection of numbers. It is known as integers. We can represent this collection of numbers in a number line. In this number line, 1, 2, 3, 4, 5 up to infinity are said to be positive integers, and minus 1, minus 2, minus 3, minus 4, minus 5 up to infinity are said to be negative integers. Here are some conclusions about integers. Every positive integer is larger than every negative integer. That is, every positive integer is larger than every negative integer. Second one is 0 is less than every positive integer. 0 is less than every positive integer. 0 is less than every positive integer. Next is 0 is larger than every negative integer. 0 is larger than every negative integer. 0 is larger than every negative integer. 0 is neither positive nor a negative integer. 0 is neither positive nor a negative integer. 0 is neither positive nor negative integer. We learned from earlier classes, integers form a bigger collection of numbers which contains whole numbers plus negative numbers. Now, in this lesson about integers, we learn about their properties and operations. So, in this number line, we marked some numbers, that is minus 3, minus 1 and 2. We can write the marked integers in the ascending order like this: minus 3, minus 1 and 2. Why we choose minus 3 as smallest number? Because in a number line, moving left from 0 means the value is decreasing. That is, moving left from 0, the value of the numbers is decreasing. If we move right to 0, the value increases. Here are some statements regarding to the number line. If we add a positive integer, move to the right. We move to the right. If we add a positive integer, we move to right. If we add a negative integer, we move to the left. We add a negative integer. We move to left. We subtract a positive integer, we move to the left. If we subtract, we move to left. If we subtract a negative integer, we move to the right. We subtract negative integer, we move to right. Properties of addition. We have learned that sum of two whole numbers. We have learned that sum of two whole numbers is again a whole number. Like 17 plus 24, we get 41. If we are adding minus 10 plus 3, we get minus 7. Plus 23 plus minus 23, that is positive 23 plus minus 23, we get 0. Negative 25 plus negative 10, we get negative 35, minus 35. So, since the addition of integers gives integers, that is, if we add two integers, we get the answer which is also an integer. We can say that integers are closed under addition. Since the addition of integers gives integers, that is, if we add two integers, we get the answer, it is also an integer. So, we can say integers are closed under addition. Now, we can say integers are closed under addition. In general, for any two integers, we can say it as for any two integers, a and b, a plus b is an integer. That is, if we add any two integers, 1 plus 2 equal to 3, minus 1 plus minus 2 is minus 3, minus 1 plus 2 gives 1. Or if we add 0.1 plus minus 2, which is not considered as an integer. Integers are whole numbers and they are negative. So, if a and b are two integers, a plus b is an integer. So, we can say integers are closed under addition. Closure under subtraction. What happens when we subtract an integer from another? That is 7 minus 9, we get minus 2. Minus 8 minus 14, we get 6. 32 minus 17 equal to 49. Minus 18 minus of minus 18 equal to 0. That is minus 18 plus 18 equal to 0. Here we see all the answers are integers. Minus 2, 6, 49, 0, all are integers. So, we can say that the integers are closed under subtraction. Here we see the integers are closed under subtraction. Thus, we can say that if a and b are two integers, if a and b are two integers, then a minus b is also an integer. Then a minus b is also an integer. That is minus 3 minus minus 2, we get minus 1. 4 minus 3, we get 1. Minus 9 minus of minus 9, we get 0. Here all these answers are integers. So we can say that integers are closed under subtraction. That is, if a and b are two integers, then a minus b is also an integer. Commutative property of addition. We know that 3 plus 4 equal to 4 plus 3 equal to 7. That is, whole numbers can be added in any order. That is, we can add the whole numbers in any manner. That is, 1 plus 2 equal to 2 plus 1 equal to 3. 10 plus 20 equal to 20 plus 10 equal to 30 in any order. So addition is commutative for whole numbers. Now let us check what about integers. Whether addition is commutative for integers. We know the commutative property of addition is true for whole numbers. Now we have to find if it is true for integers. Here we add 5 plus minus 6 equal to minus 1. We change the order. Minus 6 plus 5, we get the same answer, minus 1. Minus 8 plus minus 9, we get minus 17. Minus 9 plus minus 8, we get the same answer, minus 17. Minus 45 plus 0 equal to 0 plus minus 45, we get minus 45. Here the sums are same even if we change order. Thus we can say that addition is commutative for integers also. In general, for any two integers a and b, we can say a plus b equal to b plus a. We know that subtraction is not commutative for whole numbers. Subtraction is not commutative for whole numbers. Is it commutative for integers? Consider integers 5 and minus 3. Minus 5 minus 3, we get 8. It is a positive integer. Whereas minus 3 minus 5, we get minus 8. It is a negative integer. Here, if we change the order, we get different sums. So that we can conclude that subtraction is not commutative for integers. Thus, we can conclude that subtraction is not commutative for integers. Whereas addition is commutative for integers. Subtraction is not commutative for integers. Associative property. Consider the integers minus 3, minus 2 and minus 5. If we add minus 5 plus minus 3 plus minus 2 and minus 5 plus minus 3 plus minus 2. The first case we add minus 3 plus minus 2 plus minus 3. That is the integers in the bracket. That is minus 2 plus minus 3, we get minus 5. Then we add minus 5 plus minus 5. Then we get the answer minus 10. This is the answer. And next we add minus 5 plus minus 3. That is minus 5. Minus 5 plus minus 3. Then we reach in minus 8. The answer for this is minus 8 plus minus 2. Then we reach in minus 10. The answer is minus 10, which is the answers are same here. Here in this case, in both ways we get the same answer, minus 10. Look at another case. Minus 3 plus 1 plus minus 7 equal to minus 3 plus minus 6. The answer is minus 9. In the other way, minus 3 plus 1 plus minus 7. That is, for this the answer is minus 2. We get the answer minus 2 plus minus 7. Then we get the answer minus 9. In both ways, we get the same answer. Thus, we can say addition is associative for integers. In general, we can say for any integers a, b and c, a plus b plus c equal to a plus b plus c. That is, addition is associative for integers. In general, we can say for any integers a, b and c, a plus b plus c equal to a plus b plus c. Additive identity. Additive identity. Minus 8 plus 0 equal to minus 8. We get the same number. Minus 20 plus 0, we get minus 20 itself. The same number. 0 plus minus 6, we get minus 6. The above examples show that 0 is an additive identity for integers. That is, we get the same number. For 8 plus 0 equal to 8. It is true for positive integers also. 25 plus 0, we get 25 itself. 0 plus 50, we get 50. So, 0 is the additive identity for integers.